Hello viewers, in this video we can see another one topic from the second unit, that is enhanced ER model. The objectives of this topic is to understand about the enhanced ER model and to represent the data entities of various software systems in enhanced ER diagram. Now let us see about the enhanced ER model. As the complexity of data increased in the later years, it became more and more difficult to use the traditional ER model for database modeling. Hence, some improvements or enhancements were made to the existing ER model to make it able to handle the complex applications better. So, enhanced ER model is a higher level data model that incorporates the extension to the original ER model. So, it is a diagrammatic technique for displaying the following concepts. So, in the enhanced ER model, the following concepts will be considered: subclass and superclass relationship, specialization and generalization, union or category aggregation. These concepts are used when the EER schema and the resulting schema diagrams are called EER diagrams. Features of ER model. Enhanced ER model creates a design more accurate to database schemas. It reflects the data properties and constraints more precisely. It includes all modeling concepts of the ER model. Also, it has the diagrammatic technique that helps for displaying the ER schema. It includes the concept of specialization and generalization. It is used to represent a collection of objects, that is union of objects of different entity types. Next, first let us see about the subclass and superclass representations. Subclass and superclass relationship leads to the concept of inheritance. Superclass is an entity type that has a relationship with one or more subtypes. An entity cannot exist in database merely by being member of any superclass. For example, shape is the superclass having subgroups like square, circle, triangle. And the subclass is a group of entities with unique attributes. Subclass inherits the properties and attributes from its superclass. For example, square, circle, triangle are the subclass of superclass shape. So the subclasses will have all the properties of its superclass, but the subclass will have its own unique attributes. Hence, as a part of the enhanced ER model, along with their improvements, there are some new concepts were added to the existing ER model. They are generalization, specialization and aggregation. First one is generalization. It is the bottom-up approach in which two lower level entities combine to form a higher level entity. In generalization, higher level entity can also combine with other lower level entities to make further higher level entity. It is more like superclass and subclass system, but the only difference is the approach. Here the approach is bottom-up approach. For example, here we are seeing account is more general representation of entity, which may be of two types: saving account and or current account. So the saving is an entity which is specialized entity from the account type. So the saving and current are generalized an entity. And again we can see the examples like university member is a staff or student. University member is more generalized term. The university member may be of two categories: staff or student. Next, specialization. It is the process that defines a group of entities which is divided into subgroups based on their characteristics. It is reverse process of generalization. Here the approach is top-down approach, in which one higher entity can be broken down into two lower level entities. For example, this is an example for the specialization. Employee is more generalized entity which may be considered as a specialized entities like developer or tester. The employee may be the developer or tester. So the developer tester entities are more specialized entities, but the employee is more generalized entity. So here the view is from top to bottom. So specialization is a top-down approach. Next one is aggregation. It is the process that represents the relationship between a whole object and its component parts. It abstracts the relationship between the objects and viewing the relationship as an object. In aggregation, it is the process in which two entities will be treated as a single entity. For example, college course. College have the relationship offer with the course. College offers course. And the student is an outside entity. Student will inquire about the college or the course to the previous aggregated entities. So the student will have the relationship inquiry. So here the college and course, both entities will be considered as a single entity. For the student, the above both entities will be combined and considered as a single entity. So here in aggregation, college, course, both entities are considered as a single entity for the another one entity, student. So this is called as aggregation. And also we are seeing another examples. Sender offer courses and the visitor, again the sender may be educational institutions, offer courses. Both entities are aggregated as a single entity for the outside entity visitor. So the visitor will inquire to the aggregated entities, sender and course. And again we can see the example, project works for employee. So both entities are aggregated as a single entity, and in a system it has another entity, machinery. Machinery requires the both combined aggregated entities requires machineries. So the both project and employee entities are considered as a aggregated into a single entity for the machinery entity. Next one is category or union. Category represents a single superclass or subclass relationship with more than one superclass. For example, car booking. In a car booking, a car owner can be a person. A bank holds a position on a car or a company. Category, a owner is a subset of the union of the three superclasses: company, owner, company, bank and person. So the category member must exist in at least one of its superclasses. So this kind of arrangement is called as category or union. And also again we can say the generalization and specialization is a object-oriented concepts. In an object-oriented way, we can say that specialized classes are often called as subclasses, while a generalized class is often called as superclass. So the subclass is best understood by ease analysis. So the entity is a specialized type or class of another entity. And again we are seeing an example, employee, having many types of employees like secretary, technician, engineering. So the employee is the superclass having many attributes and the values like employee number, name, salary. Again the secretary is one type of employee. Secretary entity will have its own specific attribute like typing speed. Technician is the entity having its own attribute like trade of the trade value, and the engineer is another one entity who have one specialized attribute, engineering type. But all those specialized employees will have their own common attributes like employee number, name, salary. That is, superclass attributes are inherited to the specialized entities, but they will have their own specialized attributes also. So that will be also represented in the particular ER diagram. Now let us see the possible university question. Here only one question is explain the enhanced ER model features. So here we have to explain the various features like aggregation, specialization, category union with the proper examples. So by this we can wind up the presentation. Thank you.